Hello, my name is Raul Vera, and I'm a Senior Applications Engineer for Menlo Microsystems. I'm here today to introduce the power relay that Menlo has introduced into the product line. There are two designs that have come out. One is an MM9105 AC, and the other one is an MM9105 DC. The AC, standing for alternating current, is one that will suffice at 277 volts at 10 amps, and the DC version is a 60 volt DC at 10 amps. So now that we have the introduction of both the AC and DC units, I'd like to show you actual physical unit here. This is a prototype that we are servicing out to our customers as an evaluation unit. In my left hand, I have the control card, which does all the controlling, allowing the ideal switches to be turned on and off safely by something called hot switching. And in the right hand, I have actually the ideal proprietary switch. These are the MEM chips that Menlo has created and that are used in conjunction with the control card over to the left here in my hand. Both these units come together, and it's really one board that does both the AC and the DC, and it's firmware defined as whether it does the AC or DC. This unit allows you to, for AC, control either the zero crossing or instantaneous, and for DC we only use instantaneous mode. So now I'd like to show you that the actual ideal switch daughter card is plugged into the controller, and this is what makes up the actual power relay. And it makes it up for both the AC and the DC models. The beauty of this is that we got one evaluation card for both servicing the customer for both AC and DC. The firmware is very much the same for both an AC and DC, except there are certain functions that for DC are not required. I'd like to now talk about the applications. And for AC, they're used for the power grid, renewable energy, factory automation, motor speed control, light fanning and dimming, and communication lines. Process control industries are also using relays of this type, and unoriginal power supplies always you can find a relay. Okay, now on the DC side, we do DC motor control. There is smart electric meters. There's PV inverter solar, and there's factory also automation with EV chargers to also be used. So in the end here, what we're talking about is an eval unit that will actually be reduced to about a 30 by 20 by 10 size when this thing gets productized. So at this point here, you see the size of it as a prototype, and at this point right here, it gives you all the functionality and features you need in order for you to evaluate it in your system. So this MM9105, which can do both AC and DC power relaying functions, is a great asset to what the industry has been using in the form of electromechanical relays, which are bulky, heavy, use large heat sinks, and then the solid state relays, which also use heat sinks and take up a lot of space. Our goal is to reduce this to a 30 by 20 millimeter by 10 millimeter footprint with no heat sink required on this. The R-on resistance will allow us to have less heat dissipation in the device and allow you to be using this with more space savings and efficiencies.